Okay, so looking at this day 2 worksheet. So what we're going to do is we're going to go over some rules that we're going to need to know for our proofwriting. So the first one states the vertical angles theorem. Vertical angles are congruent if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. So we're essentially looking at this as 1 with 2, 3 with 4. So those are congruent. Looking at our second one, we're talking about the congruent supplements theorem. If two angles are supplementary to the same angle, then they are congruent. So what they're saying here is that if the measure of angle 1 and the measure of angle 2 equal 180, so this guy and this guy, and then the measure of angle 3 and the measure of angle 2 equal 180, the matches, if we just kind of got rid of that, you would see that the measure of angle 1 and the measure of angle 3 end up being equal to each other, okay? So in this case, let me erase that because we got to leave that alone. So we would state here, then angle 1 would be congruent to angle 3. And when you're talking about congruent supplements, you're talking about the thing that equals 180 supplementary. If we went down to the next one, we have the congruent complements theorem, which is essentially the same thing, just you're dealing with 90-degree angles instead, complementary angles. So in this case, again, if the measure of angle 1 plus the measure of angle 2 is equal to 90 and the measure of angle 3 plus the measure of angle 2 is equal to 90, then that means angle 1 is congruent to angle 2. I'm sorry, angle 3. Angle 3. Oops. Sorry. Again, find the pair. That's the thing you're not going to talk about. Okay? Questions on those 3 before we move on to the next, to the back side of this sheet. Anything? All right, let's take a look at right angle congruence theorem. So this is kind of like one of those dull ones where it says all right angles are congruent, right? So if you have 2 right angles, you know they're going to be congruent. So in this case, we're going to state that angle A would be congruent to angle B. If we look at this one, it says if 2 angles are congruent and supplementary, then each is a right angle. So if angle 1 is congruent to angle 2 and the measure of angle 1 plus the measure of angle 2 equals 180, then you have angle 1 and angle 2 have to be right angles. Okay? Any questions on that one? There's nothing right there. I just want to make sure that we're okay with the idea of it. Okay. Linear pairs theorem. This one is kind of big. So it says the sum of the measures of a linear pair is 180. So if you have angle 1 and angle 2 form a linear pair, then you are going to have that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Now this is different from the definition of a linear pair. Okay? What you would state here is by definition of a linear pair, you would state that angle 1 and angle 2 form a linear pair. Here's the big thing about the linear pairs theorem. You can't use this until you have this. Okay? If you don't have a linear pair or it's not defined as a linear pair in your proof, you can't use it. Okay? You're going to do something else, something supplementary. Or you can define it as a linear pair and then apply the theorem. Okay? So this identifies the angles that are a linear pair. While this states that the measures are equal to 180 degrees. Questions on this? Anything? Going once, going twice? All right, so here's some extra properties that we have. So it says some properties of equality have equivalent versions for congruence. Let segment AB, segment CD, and segment EF be any line segments. Let angle A, angle B, and angle C be any angles. So here we have the reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence. The reflexive property means that that part of a shape is congruent to itself. So for reflexive, I could have something like this. If I had a triangle, let's call it A, B, C, and then we added like a D and an E. I would state that angle A would be congruent to itself by that reflexive property because we have two triangles that are sharing angle A. Does that make sense? And then if let's say we had something like this, we had like maybe a parallelogram and we labeled this A, B, C, D. We had this line going through. I would state that line AC would be congruent to itself by the reflexive property because triangle ABC and CDA share that segment. Does that make sense? That's the pictorial version of the reflexive property. Now the symmetric property, if we take a look here, you have segment AB is congruent to CD and then CD is congruent to AB, or you have angle A congruent to angle B. That means B is also congruent to A. This one, this is your flip-flop. It means you can switch these around, okay? Let's see, what would we call that? Segments and angles flip using this property, okay? That's important because remember when I said last week when we were doing the algebra proofs, I said you have to make sure you are ending as it looks, right? So let's state just, quickly for an example, let's say you needed to prove, this thing would switch easier. Here we go. If you needed to prove that angle A is congruent to angle B, but you have as like your final step, angle B is congruent to angle A. These are not the same. So you use a symmetric property to flip them around so that it is what you're looking for. Does that make sense? Questions on that one? All right, now your transitive property is basically, it could be viewed as transitive or it could be used as substitution, okay? Technically, substitution can work with transitive, but transitive doesn't always work with straight substitution. But what we're saying here is, let's just give you a brief example. Let's say we have x is equal to y is equal to 8. So what can I conclude about x and 8? X is equal to y is equal to 8. Yeah. X equals 8. That is the transitive property. You have to have those three parts. In this case, if you look, AB is equal to CD, CD is equal to EF, then by the transitive property, AB and EF are also equal. And it works for angles as well. Does that make sense? These are all properties that you are going to see with proofwriting. Is there anything I can address before, along with other things that we've used too? Is there anything I can address before we move on to the second worksheet? Okay, I have a door prize for you guys. Something that's going to help out a lot, okay? And it's these sheets right here, okay? It's a topic 1, part 2 formula sheet. Use this for your homework. It has a lot of these properties on it. And use this for your proofwriting, okay? It's going to help. You okay, Luis? Yeah. 3, 4. Okay, pass it down that row. Please do not lose these. Do not lose these. Please, please, please do not lose these, okay? These are going to be super helpful. All right. If there's no questions on this, take out the next worksheet where it says lesson 1-7, 2-column proofs. And we're going to get into applying this a little bit. All right, so this says a proof is a convincing argument that uses deductive reasoning. A 2-column proof in which the statements and reasons are aligned in columns is one way to organize and present a proof. The reasons column can be properties, definitions, postulates, and theorems. So that sheet I just gave you contains a lot of properties, definitions, postulates, theorems that you can use for proofwriting. Hold on to that. Don't lose it. Okay? Now let's take a look at our first example. It says fill in the blanks for each proof below. So in this case, when you are proofwriting, just like we did last week with those algebra proofs, you're always going to start with the given. So in this case, they're telling me that angle A is a right angle and angle B is a right angle. So I'm going to write that in. Angle A is a right angle. Angle B is a right angle. So if you guys look at this, the back side, let's see if we can find something that'll actually help. We're stating that angle A is going to be congruent to angle B. Why is that? Just in general, why is that true? We have two right angles. Angle A and angle B are both right, but now we're saying they're congruent. Why is that true? Well, what do we know about right angles? Yeah, they're 90 degrees. And if they're both right angles and they're both 90 degrees, then they're both what? The same, which means they're equal to each other, right? Does equal and congruency kind of match up a little bit? Yeah. So we could state here, because we know those measures, that all right angles are congruent. And if you look, that is all the way down. It says the right angle congruence theorem. All right, let's take a look at our next one. So given JK is 2.5 centimeters and NO is 2.5 centimeters, and that's my given, so I'm going to write that in. JK equals 2.5. NO equals 2.5. That's given to me. Now they're saying make the conclusion that JK is equal to NO. So in this case, we know they're both equal to 2.5, which means what? They're equal to... Let's think of it this way. If JK equals 2.5 and NO equals 2.5, then what do we know about JK and NO? They are what? They're congruent. They're equal to each other, right? So that's the next step. We're going to have to say JK is equal to NO. Now, if you guys take a look here, you got to talk about the measures before you can go into congruency and vice versa, okay? If there's no line above these, that means we're talking about the segment measure. Like it's think of it as like the M of the angle. Remember how we have the M for an angle measure? All right. So what we're going to state here is we're just going to state that this is either transitive property or substitution. The choice is yours. I'm going to apply transitive property here because we just kind of went over that and I want a decent example of it. So now if these are equal, we know that they're congruent, and that is just by the definition of congruent segments. Questions on this? How we doing? All right, let's take a look at number 3. So number 3 states XYZ is a right angle. So this entire angle is a right angle. So I'm just going to put a little square there. Another thing with proofwriting, guys, mark these up if you want to. Use different colors if you want to. It's going to help out a lot. Okay. So that's the first I'm going to write down. Angle XYZ is a right angle. That's given to me. They want us to prove that the measure of XYZ is 90 degrees. So what am I going to state here? First off, is it true that it's 90 degrees? Yeah. So I'm going to put here the measure of angle XYZ equals 90. But the question is, what's the property or definition or theorem? Guys, look on that back side. What do we see? No, actually, this one I might have to give to you guys. Sorry about that. I thought it was on here. It's not. All right, so this is going to be the definition of a right angle. Okay, and that makes sense, right? Because we know by the definition of a right angle that we get a 90-degree angle, right? Not to use the word right too many times, but yes. All right, let's take a look at number 4. So it says the diagram, we have to prove that angle 1 is congruent to angle 2. So if you're ever given a diagram, you would just write down diagram. The diagram is given to you. That is what you're using for this proof. So what do we know about vertical angles? They're what? They're vertical, yes, but what are they? Begins with a C. They're congruent. Vertical angles are always congruent. So if we're looking at just angle 1 and angle 2, we would just go right into it. Angle 1 is congruent to angle 2, and this would be by the vertical angles theorem. And that's what we learned in the last sheet. It's right there. I think it's also on the back of that other sheet I just gave you, the one with everything on it. Yeah, it's on the back. It's like right at the top. All right, so far, what questions do we have? All right, I want to go. Does anybody need? We have these 2 additional examples. Does anybody want me to go over them just to kind of solidify anything? Okay. Here is the one thing I do want to go over with you guys real quick, and then I'm going to just let you get to your homework. So you guys got this. Fill in the blank. This one's fill in the blank too. Look at number 4. 4 gives you what type of angles there? Who can tell me? We just talked about it. Good. They're vertical angles. So I'm going to take these 2 and do what with them? Yeah. So this one, you're setting everything equal. Okay. One to the other. Number 5. This, I'm going to fill some stuff in. This says if JK is perpendicular to HI, so it's got that mark right there showing that right angle. The measure of angle 1 is 50 degrees, and the measure of angle 2 is 8x minus 8. They want you to solve for x. So what am I going to do with these 2 angles? How am I going to set up the equation here? Who can tell me? What do you guys think? Well, let's see. If this angle is 90 degrees, then what is KJI going to be? Okay. 90, right? So that's going to be 92. So if that's 90, then I do what with these 2? It's an operation. I'm going to add, subtract, multiply, or divide. Add them. So you're going to add those 2 and set it equal to what? Add and set equal to how much? $90. So there's that tip for you. Okay. D, I'm going to let you try to figure that one out on your own. Okay. All right, questions. All right, so your homework for tonight is going to be this 1 through 6. Okay. All this, do the triads too. All right. And then you also have a Delta Math. I think it's like 9 questions. And it's more like, what is that? Like, what is this? What is that? Kind of a thing. They're just going over rules mostly for about half of it. Okay. Questions? The remainder of the Google Slides, I'll have you finish that after tomorrow. I'm not going to make it due today, okay? Because we're not going to go over it. I'd like to give you guys a little bit more practice with geometric proofs. Okay. That's it. You guys can get working.